few seconds to fell, and with one decisive tilt of the vessel, tons of timber hit the river. That's how logs make their way from the deep woods to the mill. But the journey that follows is even more impressive. Join Raw Machines as we follow these trees from the forests of Nova Scotia to state-of-the-art sawmills, where massive machinery, laser systems, and AI work together to maximize the value of every single log. Let's dive right in. Every journey has a beginning. For wood, that beginning lies in the legally managed and sustainably harvested forests of Nova Scotia, Canada. Once everything is in place, the feller buncher moves into the harvesting area. At first glance, it looks like a large excavator, but mounted at the front is a hydraulic cutting head capable of gripping and severing an entire tree trunk in just a matter of seconds. What's remarkable is that as soon as the tree is cut at the base, it doesn't immediately fall to the ground. Instead, the machine continues to support the full weight of the trunk before carefully laying it down in a precisely planned direction. This approach not only improves harvesting efficiency, but also minimizes impacts on surrounding trees, reducing disturbance to the surrounding ecosystem. However, the job isn't finished yet. The rugged terrain, soft ground, and long distances make conventional logging trucks nearly useless. That's when another essential machine comes into play, the forwarder. Its sole purpose is to collect and transport logs. Using its hydraulic crane, it loads each log onto the cargo bed at the rear, then carries the entire load to the designated landing area. The next stage of the journey unfolds on the water. For logs that are exceptionally long and heavy, water transport has long been the most efficient solution. A single barge can carry as much timber as dozens of logging trucks combined. After several days in transit, the barge arrives at the log receiving facility. What happens next often surprises first-time observers. The entire barge slowly tilts to one side. Within moments, hundreds of logs slide off the deck and splash into the water. This isn't done at random. The water itself serves as a natural conveyor system. Thanks to their natural buoyancy, the logs float on the surface, where tugboats gather them into large bundles before towing them to sorting areas or the mill's log intake. Finally, after hours of hauling through forests, navigating roads, and traversing waterways, the timber finally arrives at the receiving yard. From this point forward, these logs are poised to embark on a completely new life cycle, where precision lasers, razor-sharp saw blades, and cutting-edge industrial technology await them. The newly arrived logs cannot proceed directly to the processing lines just yet. Before entering the primary mill, they must undergo a critical preparatory step, debarking. It may sound simple, but this stage plays a vital role in determining cutting accuracy, extending the life of the saw blades, and ensuring the quality of every board produced later on. This machine looks like a large cylindrical tunnel with dozens of rotating steel rollers and toothed drums inside. As each log passes through, the rollers grip it tightly and spin it in opposite directions, stripping away the bark in just a matter of seconds. You might be wondering, what happens to all the bark after it's removed? In reality, very little of it goes to waste. The bark is collected and reused right at the mill. Larger pieces are processed into landscape mulch, while smaller particles are compressed into biomass pellets. These pellets are burned to generate heat for the mill's drying kilns and heating systems, reducing reliance on fossil fuels while helping lower carbon emissions. Beyond energy production, bark is also used as a soil amendment and landscaping mulch. It helps retain moisture, suppress weeds, and gradually return nutrients to the soil. It's a great example of how the modern wood industry turns what was once considered waste into a valuable resource, creating a production process that is more efficient, environmentally responsible, and sustainable. After shedding their rugged outer coats, the logs advance into a quiet yet commanding arena, the 3D scanning station. Here, laser arrays and X-ray sensors scan each log at a rate of millions of data points per second, creating a highly detailed digital model accurate down to the millimeter. The system doesn't just capture the log's external shape, it also sees beneath the surface, revealing hidden details such as the grain pattern, the location of knots, tiny internal cracks, and the complex structure of the wood fibers. In the past, these decisions relied heavily on the experience of skilled sawyers. Today, AI can analyze all of this data and determine the optimal cutting strategy in just a matter of seconds. It's a shift from traditional craftsmanship to intelligent manufacturing, where every decision is driven by data. Next up is the primary sawing stage. But before the saw blades can fire up, the system must ensure one crucial thing: the log is perfectly positioned. A laser array performs one final scan, cross-referencing the physical position with the data just calculated by the AI. Only when every parameter matches completely does the assembly line swing into motion. The alloy saw blades rev up to thousands of revolutions per minute, while a system of hydraulic rollers clamps the log tightly and feeds it forward at a steady pace. Each precise cut gradually transforms the round log into square blanks, also known as cants, the standard raw material for the subsequent processing stages. Throughout this process, an array of sensors continuously monitors the feed speed, vibration, pressure, and blade temperature. Any deviation is adjusted almost instantly to keep the cuts perfectly stable. Looking back at the freshly cut cants, you can clearly see the beautiful contrast between nature and technology. From the random wild shape of a forest tree, it has now become square, clean, and uniform blocks of wood. Following the primary sawing stage, the square cants are transferred to the secondary cutting line. If primary sawing shapes the foundation, this is where every single centimeter of wood is utilized to its absolute maximum. From these large cants, the mill breaks them down into dozens of smaller boards, each with its dimensions, thickness, and grain orientation optimized for specific types of pallets. The cants pass through an optimizer saw line and a multi-rip saw system one by one. In front of each blade assembly, cameras and optical sensors continuously inspect the surface of every cant. Any dead knots, cracks, grain deviations, or minor deformations are immediately detected and fed back to the processor. Once again, the AI kicks into gear. If a knot is located near the edge, the system can adjust the cut to isolate and remove the defect while leaving the remaining good wood perfectly intact. If the cant has a slight sweep, the blade positions will shift accordingly to maximize the usable width. Instead of applying a one-size-fits-all dimension, each cant is processed based on its own unique characteristics. That is why, on the exact same line, two logs of nearly identical size can still yield completely different combinations of boards. After a series of consecutive cuts, the large cants are progressively divided into multiple boards of varying widths and thicknesses. Right at the end of the line, automated robotic arms begin preliminary sorting. Boards that meet the quality standards move on to the next stage, while those with too many defects are separated to be recycled into wood chips, biomass pellets, or other industrial products. Once again, virtually no part of the tree goes to waste. As the boards leave the multi-saw system, they have already taken shape, but their edges still retain rough bark remnants and the natural curves of the original log. This is where they enter the edger, a machine where nature's organic form gives way to the precision of perfectly parallel lines. Here, an advanced optical sensing system serves as the machine's eyes, instantly measuring the usable surface area and identifying any remaining wane along the board edges. Within a fraction of a second, the computerized control system calculates the optimal cutting pattern and commands the two saw blades to automatically adjust their spacing, making clean, decisive cuts along both sides of each board. The result is a set of boards with uniform widths, smooth, straight edges, and consistent industrial-grade dimensions, ready for grading and quality classification in the next stage of production. This is the final stage of the primary lumber processing line, and it is also the step that determines the intended use of every board. The process begins with end trimming. A laser precisely measures the length of each board as it travels along the conveyor. Based on pre-calculated specifications, a crosscut saw trims both ends to produce a standardized length, typically between 1,000 and 1,200 millimeters, or according to the requirements of each order. The short offcuts removed during trimming are not discarded. Instead, they are collected and sent for recycling. Each board then enters an automated grading system. AI analyzes its color, grain pattern, flatness, brightness, the number of knots, cracks, and many other quality characteristics. Based on this analysis, a combination of pneumatic actuators and automated diverter gates directs each board into the appropriate grade. High-quality boards are used for export pallets and heavy-duty structural applications. Boards with minor defects are suitable for industrial pallets, while the remaining material is recycled into other wood products. After being sawn and sorted, the boards are not quite ready for the drying kiln. If stacked directly on top of each other, air cannot circulate between the layers, causing uneven moisture loss and increasing the risk of warping or splitting. That is why modern mills utilize an automatic stacking system to handle this task. On the line, robots continuously pick up each board and stack them into neat layers. After each layer, the system automatically inserts thin wooden strips, called stickers, to create gaps that allow hot air to circulate freely. Once completed, the stacked boards are bound into large packs, then fitted with barcodes and electronic tags that store information regarding their type, dimensions, and production time. This allows thousands of lumber packs to be tracked, retrieved, and moved seamlessly 24 hours a day. Leaving the orderly setup of the stacking station, the lumber packs enter one of the most critical stages in the mill, kiln drying. Inside the kiln, the temperature is typically maintained between 140 and 195 degrees Fahrenheit, while a convection fan system continuously drives hot air through the gaps between each layer of boards. Over several days, the water inside the wood gradually evaporates, dropping the moisture content from around 50% down to 12 to 20%, which meets the strict standards for pallet manufacturing. The entire process is monitored by moisture sensors and a computerized control system. The fan's temperature and evaporation rate are constantly adjusted to ensure the wood dries uniformly from the inside out, minimizing any cracking, warping, or deformation. Upon exiting the drying kiln, each board is significantly lighter, with a brighter surface and much higher stability than before. From here, they are ready to enter the final stage, detailed machining and assembly into completed pallets. Conveyors feed the boards into the machining workshop one by one. Here, cross-cut saws and rip saws work in tandem to produce components with precise dimensions. The deck boards are cut to standard lengths to directly support the goods, while the stringers are machined separately to form the load-bearing frame of the pallet. Throughout this process, a laser system continuously checks the dimensions of each component. If any deviation is detected, the blade positions are adjusted instantly, keeping the margin of error within a 1 mm tolerance. This level of precision is critical, as even a single out-of-spec component can compromise the stability of the entire pallet under load. As for the stringers, they must undergo one additional step: notching. A notching machine uses high-speed milling heads to cut U-shaped or L-shaped notches into both sides of the wooden stringer. These notches allow forklift tines to access the pallet from multiple directions, meeting modern logistics standards. Before leaving the workshop, all components are passed through planers and sanders. The surfaces are flattened, sharp edges are slightly eased, and small splinters are removed. Some production lines also utilize automated wire brushes to clean the surfaces, making the components more uniform and safer to handle. At this point, every individual puzzle piece of the pallet is complete. They are sorted, grouped, and sent directly to the assembly line. At large-scale facilities, the entire process is almost fully automated. A positioning system places the stringers in the exact location before dropping the top and bottom deck boards into place according to the design blueprint. Within seconds, high-speed industrial nail guns fire away, securing the entire structure with galvanized steel screw nails that offer high holding power and heavy load capacity. The spacing between boards, the placement of each nail, and the squareness of the structure are all automatically controlled, ensuring every product is completely uniform upon leaving the line. smaller mills, many steps are still performed manually. Workers coordinate smoothly. One places the stringers, another aligns the top deck boards, and another secures the bottom with handheld nail guns. Although lacking the high automation of modern lines, product quality here depends heavily on the experience and precision of each individual craftsman. A standard pallet typically consists of load-bearing stringers combined with 10 to 12 top and bottom deck boards, bonded by dozens of specialized steel nails. At first glance, its construction appears quite simple, yet it is fully capable of supporting cargo weighing several tons throughout shipping and warehousing. This brings us to the final stage of the manufacturing process, packaging and distribution. After passing the final inspection station, the finished pallets are automatically conveyed to the packaging area. Each bundle, typically containing 10 to 20 pallets, is tightly secured with either double steel strapping or heavy-duty plastic bands, ensuring the entire load remains stable throughout long-distance transportation. Forklifts move one after another into the shipping area. As warning alarms sound, each bundled stack of pallets is carefully lifted and smoothly loaded into waiting shipping containers or trucks, ready for delivery. Few people realize that nearly every product we use in our daily lives, from food and electronics to construction materials, has, at some point, rested on a wooden pallet somewhere along the global supply chain. That seemingly simple wooden pallet is the foundation that enables goods to be stored, handled and transported safely and efficiently. It may not be the most celebrated product of the wood industry, but it is undoubtedly one of its most essential, quietly connecting factories, seaports, distribution centers, and markets around the world. Perhaps, after following this entire journey, we will never look at a wooden pallet the same way again. Behind that seemingly simple structure lies a whole chain of processes spanning from sustainably managed forests and giant harvesting machines conquering rugged terrain, to factories where lasers, artificial intelligence, and automation work together to make the absolute most of every single wood grain. Every step is precisely calculated to achieve two seemingly contradictory goals: creating more value while wasting fewer resources. What's truly amazing isn't just the sheer scale of modern production lines or the operating speed of thousands of machines. The greatest value in today's wood industry is how humans have learned to work in closer harmony with nature. A tree that takes decades to mature is harvested according to a plan, utilized almost in its entirety, and continues to contribute value in many different forms. From the main lumber boards to the bark, sawdust, and wood chips, virtually nothing goes to waste. Yet behind all the machinery, technology, and smart algorithms, there are always humans. They are the engineers designing the production lines, the operators running machines deep in the forest, the workers monitoring every stage, and the experts constantly looking for ways to utilize resources more efficiently for future generations. From a seed taking root in a Canadian forest to a pallet appearing in a warehouse anywhere in the world, that journey tells more than just the story of wood transformation. It is also a story of the synergy between nature, human labor, and modern technology to build the foundation of the global supply chain. Because sometimes, the most important products aren't the ones that stand out the most. They sit quietly beneath every shipment, silently supporting the global economy, much like how forests have silently nurtured human life for thousands of years. Thank you for listening until the end of the story. If you love videos like this, please like, share, and subscribe to the channel so you don't miss our next stories. This is Raw Machines saying goodbye and see you next time.